I'm going to be talking about a distributed version control system called Git and the GitHub platform. And, this was really made to be a bit of a workshop. So in the second part, we'll do it together. So for now, I'll kind of outline it and emphasize the kind of theory of Git and how it works. And then we'll do a second pass where we actually use Git. And hopefully that will hammer it home. So let's begin. So the first thing, of course, is Git itself. And in the slides, I have here a link to the downloads. Git, again, is this distributed version control system, and it's an open source version control system. It was actually created by Linus Torvald, the creator and maintainer of the Linux kernel. And he did it because the Linux kernel has over 14,000 individual contributors over the course of 3 decades. And this was the only version control system that could even accommodate this many people contributing to it. So this really propelled Git to be the de facto version control system today. There are some other version control systems, but most people are using Git. And with Git is GitHub. So these are two different things, but they work together in tandem. GitHub, as its name might suggest, is a platform for Git. It's currently owned by Microsoft, and it's used by many open source developers. GitHub has over 370 million repositories today, and like 30 million of those are public. And it has many different features for so-called social coding, right? It's really revolved around the idea of empowering people to collaborate on code together and to share their code with others. Another thing that we'll be looking to install is Visual Studio Code. This one is also developed by Microsoft. It's not to be confused with Visual Studio. Visual Studio Code is a cross-platform fancy text editor, and it's really helpful for writing code in basically any language through its extensions. It also has very good Git and GitHub integrations, which is part of the reason I've included it in this lecture. Many of the examples I show later on, I'll actually be using Visual Studio Code and the Git Lens extension. So that leads me to that extension, the Git Lens. This is a third-party open source extension for Visual Studio Code, and it has a lot of deeper integrations with Git and GitHub. It will show things like who wrote a line of code when you're looking at in the code base, and it also has some very nice visualizations for viewing the history of your code, among other features. And so with those things installed, the first thing that has to be done when you have Git on your machine is to set it up with these commands. In particular, basically when you make a commit with GitHub, it's time-stamped as to when it happened, it's hashed, you get a checksum, and authorship information is saved. So we need to know like who is writing the commits, and so for that reason, you have to configure Git after you've installed it with your name and email address so that your commits will have kind of your signature on them automatically. Another step to getting started is actually ensuring that you're able to push your code to GitHub, the platform. And to do this, you'll need to generate this RSA key pair so that you can securely authenticate yourself with GitHub and transmit your code to GitHub in a cryptographically verifiable way. And we'll talk about how to do this. It's a few commands on your system, and then you'll basically add your public key to your GitHub account, and that lets GitHub authenticate that you are, in fact, the person who sent the request. So we'll get to that. And once you have your GitHub account created and you have a way to write and authenticate with GitHub, you'll be able to start actually making repositories and contributing to them on GitHub. So GitHub has a way to create repositories, of course. It will be shown in this plus icon near the top of the page. And when you create a new repository, you specify the name, description, you say whether it should be public or private. GitHub now offers unlimited public and private repositories, but many of the tools, including this GitHub extension, are free to use when it's public and not free to use when it's private. The other aspect of creating a repository is a license. There's various licenses out there in the GitHub community. GitHub has some documentation resources on licenses. And basically, there's some licenses that are very permissive. They allow anyone to use your code. And there's other licenses that basically perpetuate open source. So they say you can use the code as long as other people who use that code also make their code open source and attribute you for writing the original code. So these are things that GitHub has you do, and I definitely recommend doing them when you create a repository. Through the course of our workshop, what we'll do is fork this demo project that we've set up for you. And it has an existing history with some very minimal changes that we can kind of explore to get a hang of how Git works and better understand how it works in general. So to fork a project on GitHub, there's, whenever you're looking at a repository on GitHub, there'll be this fork icon on the top right. And when you make a fork, what it does is it replicates the entire project and all of the code history and creates a new one on your account. So then instead of, in this case, MindLab GitHub project demo, when we fork it, we'll get a new one that has my username here, GitHub project demo. And so I've done that here. And once you actually fork it, then you can now clone it. So whereas forking will replicate the repository and all of its history onto your GitHub account, cloning it will replicate the repository and all of its history onto your computer. And this is kind of how GitHub works. Whenever you move things around, you move everything, not just the current state of code, but all of the history of that code. And that's a very important part of the capabilities of Git. Yeah, so let's go to the next one. So once you have your repository forked and then cloned onto your system, you can open that directory in Visual Studio Code. This is what I recommend, so this is what I'm showing here. And when you've done that, in particular, if you have the extension that I suggested earlier, there's this graph icon on the bottom left. And clicking that will show you this fancy rendering of the history of this project. Another way to get this information is with the command line git command. So to get a similar type of output, it's this git log -- all -- graph. So you can kind of start to get the sense that the command line can be used to do everything in Git, but you can also use some visual interfaces if you need to. To basically what we're looking at here with these entries are different changes that were made to the code base and then committed, and a description was provided for each of those changes. We can see the author, which is myself. We can see when the commit occurred, and then we can see a checksum of what those changes entailed. Each change here, you can see there's this branching factor. So basically, you can, whenever you make a change, you apply it on some particular previous version of the code base. And things can happen in parallel or sequentially. And this is really how GitHub supports collaboration, because if anyone is making code changes at the same time as you, they're operating in parallel. And the later on, you're able to bring them back together. So the last thing I'll say is that we have these labels on top of each branch. And basically the label is in some ways the top of the branch. So we can work our way backwards. So whenever we have a piece of like a view of the code, we can work backwards to go all the way back to the start of the repository. So when you go this way, you're applying changes that you made. And when you go the other way, you're undoing changes that you made. And basically these branches mean that we're applying a different set of changes to some common parent. And Git is going to have tools to be able to bring these changes and rectify them and unify them. So if multiple people make changes in parallel, we can still get to a single view of the code base. So at a glance, I made this little document that kind of goes over some of the terminology and the lingo that is there in Git. So on one hand, you have your workspace. This is the code that you're actually looking at any given time that you can browse on your file system and edit with your editor. And your workspace exists independently of the entire repository. When you run the git status command, it shows you kind of the differences between the head branch of your repository, so where you currently are in the Git history, the differences between that and your workspace. So here we can see in this small example, I have some changes to this file called README, and then I have this U, which means it's untracked. So this main.py does not exist in this theoretical repository. And if I run this git add command, I'm able to move things that are not staged into staged. So this is like preparing, I want these changes to go into my commit. And the commit will again end up in the repository, and it's there kind of permanently. So we start from our workspace, we check what is different between our workspace and what's at the top of our repository. We prepare things to be committed, and then we commit them. Once we commit them, we create a commit. And a commit is a diff object, which again has a timestamp. It has authorship information, who actually made this commit. It has this hash we just talked about. And it has typically a message that you label that commit with. So because you may change multiple files in any given commit, it's very helpful to have useful commit messages. so that you can kind of see what actually happened as you went from this state to the next state. Once you've made a commit, your changes have been captured in your local repository. These only exist on your machine. They're not on the internet anywhere. Then there's these two commands. There's git push, which will sync your local repository, which is this database of changes, to the remote repository, which in this case would be on GitHub. And then the way to go backwards. So if someone made changes to your GitHub repository, or you made them in, from a different computer, you could run this git fetch command to sync the changes in the remote repository to the one on your disk. So hopefully this is not too elaborate yet, but we'll get there. So the changes on your remote and your origin, your local and the remote repository will be the same after you've run git fetch. But that does not necessarily mean that you'll be looking at the same workspace. So that will be a little different, right? Because again, the workspace is somewhat detached from the repository. We can change the workspace, and I'll show you examples of this soon. Okay, so we'll get right into it by actually using Git and seeing kind of how you collect these changes into commits and then actually run them. So here I had a file and then I made a change to it. And Visual Studio Code has this nice diff feature where after you've made a change and you click on the changes, it shows you this mode where it shows this is what it was previously, i.e. in the Git repo, and then this is what it is in your workspace. So this is what changed. And if we run this git status, we'll see that it was modified, and that's why it appears here. And we can run git add, or in Visual Studio Code, you can click this plus icon, which is equivalent of running git add, and that will move them from just changes into staged changes, right? Then we can write our message and make a commit. So in the user interface, we write the message here, we can click commit. From the command line, it's just git commit, and then you provide the message as a argument. And once you've done that, you've created a commit and it's now in your local repository. Once it's in your local repository, so I've done that here, and we can see if I look back at this git log graph, or the graph of the git lens extension, we can see our new commit. So I wrote in the message capitalize test.py, and so we can see here capitalize test.py 19 seconds ago that I made this commit. And then we can also see that we now have this option to sync changes. This is what I was talking about before, where our changes exist in our local database, but they don't yet exist in GitHub. So to get them in GitHub, we would sync the changes or run the git push command, which is what sync changes will do. Another thing to note is that now we have a master here and master here. Again, because we have two different repositories, we have the local one and the GitHub one. What we're seeing here, this master, if we hover over it, it will show us that this is actually origin/master. And then this other master is just master. And what is this referring to? This origin/ origin is a label that's referring to, in this case, GitHub, the remote repository. So we kind of have we are keeping track of what our remote repository has labels for, as well as what our local repository has labels for. The other thing here is this a special term head, and head always refers to what is current, what you're currently looking at. So head will always be where you are, and so head moved up, but the remote repository's head, or what you would see on GitHub, is still behind. But once we've synced changes, all things will kind of rectify and they'll become in sync. So let's see, what else can we do? We can also browse in the past. So because we have all the changes throughout time, we can move around. We can see what did our code base look like in the past. So to do this, one thing we can do from the UI is to locate the commit that we want to navigate to, and then we can right-click it and say switch to commit. So in this particular example, I moved back to the previous commit before we made this capitalized test.py commit, and I say switch to commit. From the command line, we would run the git checkout command. And once I've done that, you can see that the head shows up here, that we are now looking there instead of at the top one. And if we look at the actual code, we'll see that the change we just made is no longer there in our workspace. So the change we made has not been deleted. It's just not visible to us because it's elsewhere, but it's still there, is essentially how that is working. Another thing we can do is create a branch, right? So let's say now we want to start making changes from this previous location instead of from the top. So to create a branch, you can right-click and create branch, or from the command line, it's git checkout with this -v option to create a new branch. And when you do that, we can see on the visual Git lens feature that the new branch label goes there along with the existing origin master label and head. So they're all pointing to that location in history. But now that we're in a new branch, any changes we make will happen kind of parallel to this old master branch. So let's basically make a commit, but instead of actually writing a commit ourselves, we're going to make a cherry pick. So a cherry pick is a way of applying the changes from a commit on top of your current branch. So in this case, what I'm going to do is this change we made where we capitalized test.py, I'm going to cherry pick it on top of this new branch that we have. So when I do this, we can see that this creates a new branch. We have the new branch, and so that comes up, but the master stays behind. And even though we've done the same thing, we ended up with a different checksum. And this is just by nature of how Git actually does the checksumming. So we have the timestamp has changed basically, right? So it's not exactly the same. And so now we have these two diverging branches, even though they are actually the same at the end of the day. But just to kind of demonstrate that, you can kind of manipulate the history in this way. So I hope this is not too confusing so far, but basically this git cherry pick is the command you would use to do this. And the primary use case for this would be if you made a change from some other branch, and then you realize that this change would be useful, like on the main branch. You could cherry pick it on top of the main branch, and then you don't have to like copy paste your code changes, right? It's just like you apply those changes. Finally, we have the merge, and this is maybe the most useful feature of Git. And so when you merge things, you're saying, okay, we made two different changes in parallel, and we want to get a unified view of the code base. And this is really what permits people to collaborate in parallel, independently. And so to do a merge, what you do is you always merge from where you are, you pick somewhere else that you want to merge into yourself. So we're currently at this new branch location. And what we're going to do is merge, I believe I'm merging the without test branch into the new branch, right? So this without test branch is another branch that I had in the repository to begin with. And so we want to basically get a unified branch. We have our changes we just made, the capitalized test.py. We have a few changes in master, but we had some changes in without tests. So we'll merge those. And when we do that, we get a conflict. This was by design. If you're lucky, you don't get any conflict, but sometimes you get a conflict. So we can see when two people make changes in parallel, or the same person, but if changes happen in parallel that affect the same line, then you're going to get a conflict. If those changes affect different lines, the conflict doesn't occur because Git is able to automatically just apply the changes independent of one another. But if you both made the same change or changed the same line, you get a conflict. And so we can see in the Visual Studio Code interface, when we make a merge, if there's ever a conflict, we get this exclamation point mark, and we can see the files that have the conflict. If we click it, we get a diff, and it shows us, okay, on the branch we're currently on, we did this. And on this other branch we had that we're trying to merge, we did this other thing. And so now it's your job to figure out which one to keep and which one to throw out. Or in some cases, you have to manually rewrite it in a way that preserves both changes. Maybe someone changed the way print even works and someone else changes the content of it, right? So it's just something that has to be manually looked at and dealt with. In this particular case, we can see that the second one actually has a syntax error. And so it's a bit of a no-brainer to take the current changes rather than the other changes. And so in VS Code, we can just click accept current changes, or we can just remove these extra annotations that it created. And once we've saved this files with our resolved conflict, we can click the plus or stage the conflicting file that has been fixed. And then we can finish and write the merge commit, which we can see gets populated automatically. Once we have done that and we write our commit, we can see that we get this without test branch that had this final change, got merged along with the capitalized test into this new commit. And the commit is a merging commit, so it says merge, this and that. And so that's how it looks like in the history. And the nice thing here is that in this without test branch, we actually brought in some additional files that were created in that branch. But let's actually make it go else. Let's make it point to this other thing. So in this case, I'm switching. We're gonna make, let's see, what do I do? So here I checked out master, and then I moved master to the new branch, right? So what's happening is we created this new branch, but what we actually want to have is master be new branch. Whatever we did to master, we don't actually care about anymore. So what I do is I first switch to that branch, because when you do a git reset, it affects the branch you're currently on. So I switch to the branch with checkout. Then I reset the branch to be that new branch, the merged commit that we made. I do a hard reset, which will delete any loose files that we have in our workspace. Once I've done that, we can see that we get now our master shows here with the merged branch. We can actually push master now. Master and new branch are there. We never pushed new branch. We could do that if we wanted to, but I only pushed master. And now master is reflected in our GitHub repository. And so if we go on to GitHub, we can now see this capitalized test.py that we made. We can see the merge remote tracking branch that we made. And then we can also review the differences on GitHub through the user interface. GitHub lets people review those and make comments on changes that were made and whatnot. So now that we have done that, just to talk about, if someone made a change on your remote, we would have to pull it. So in this situation, we can see that Visual Studio Code periodically checks for this. And if there was a change on the remote, you'll click Sync Changes. So I did this in a copy of the GitHub repo that I just had on the side and wasn't changing. So after making the changes to this version, we get new changes. And so if I click Sync, we can see that basically the changes come into our workspace, assuming there's no conflicts. Though if we do, this git pull or this sync, and it overwrites something in our workspace, it will give us a conflict that may just not allow us to do it until we remove the changes from our workspace. So getting changes from remote, you have to run this git fetch, which Visual Studio Code runs, and then the git pull to actually unroll those changes onto your repository. So at a high level, just to recap, we have our local work tree. All the changes we make need to be staged to this place called staging, where we add things we want to put in the commit, or we remove them from what we want to do to the commit. Once we have the staged files, we can commit it. This registers it in our local repository. Then we can use the git pull or git fetch to sync between our local and a remote repository. And finally, there's this other step, a so-called pull request and a sync that allows us to sync our forked repository to the repository we forked from. So a pull request will request that changes you made to your GitHub repository get synced to someone else's repository. And this is really how the community of GitHub can actually function, because we can all work on repositories independent of one another. And then through the pull request process, we can deal with these merge commits, these merge problems in a collaborative way. Yeah, so a pull request looks like this. Once you have pushed your stuff to GitHub, you'll get this icon that says create pull request. You specify where you're making the pull request, and then you can say create pull request. You can add a message about what the pull request entails, and those pull requests end up in the repo, and they look something like this one. Some changes were made. You can see the conversation, the commits that were made, and those commits can be reviewed by the maintainer of the repository, who can add comments on a diff line by line basis or more broad comments. They can also run tests against it and various other things. More on GitHub. Of course, just like in Visual Studio Code, you can review history of things. You can also do this on GitHub. GitHub also has this issues feature, which lets you say, okay, so there's a problem with a part. So you're not contributing any code per se, but you're contributing in the sense that there's a problem with a piece of software and you're requesting a change. So definitely, if you run into problems with Appyters, the issues would be the best place to get those addressed. Yeah. So in summary, what we've talked about, we installed Git and Visual Studio Code. We set up a GitHub account, or we talked about doing those things. We showed how to fork a GitHub repo. We talked about some Git fundamentals and kind of went over using Git by example. We used Git to review some source code history in this demo project I showed. We added some of our own changes to the repo, and then we used Git to help merging those changes. So that's that. And then I have a cheat sheet here. So there's a bunch of Git commands that I went over. I don't expect you to learn them all. There's a lot of terminology and jargon, but Git, the website, has a bunch of very nice cheat sheets and helpers. If you understand this, how the graph is working. Sorry about that. If you understand how this whole graph is working and how things move between each other, it'll be a lot easier to search for the command you need to do that. Yeah, and with that, I'll just acknowledge the lab, and we can move to the demo.